Okay, so that video ended kind of abruptly. I'm sorry about that, but let's go back to that first example. And I mentioned that I would show you why I didn't do the constant factor here. And really that was just because I wanted us to see an example that would have one first. So in this one, this does not have a constant factor a, but I will write that in right now. So let's pretend that I had a times x minus 4, and we were wanting to test out what value of a we need. So I could use the y-intercept to do this, but really we can use any point on the graph that we haven't already used. So if we had another point that we wanted, like this kind of looks like 1, 3 is a valid point, but I'm not fully sure, so I'm not going to use that point. But I do know that 2, 0, 2 is 1, so when y is 2 and x is 0, this would satisfy the equation. Plugging this in, I'm just going to simplify it a little bit. We've got 2 equals negative 4a in the numerator, negative 2 in the denominator. I can multiply that 2 over and get negative 4 equals negative 4a, so a is 1. You do need to check to see if there is some kind of constant factor, but for this first one, there was not one. For the second one, we did see that constant factor of 2. Let's go to the third one. Here we have multiple key features that we can see, and I start usually with those vertical asymptotes. So there's a vertical asymptote at positive 1, another one at negative 4, yep, and there's a hole. All right, so this hole is at 2, negative 2. Just those key pieces right here tells me I have a function with a factor of x minus 1 in the denominator because of the vertical asymptote. A vertical asymptote is when the function is undefined, so we know it's undefined when x is 1. That would happen if I'm trying to divide by 0 here in this denominator. I also have a factor of x plus 4. We have a common factor of x minus 2 in the numerator and denominator, and that's what made the whole at x equals 2. All right, we're using the x value, not that negative 2. That just happens to be a coincidence. But positive 2 is where the whole occurs on the x's, and that is coming from this factor of x minus 2. Then I go to the x-intercepts. So we have an x-intercept sitting over here at 6, 0. That means I would have a factor of x plus 6, sorry, x minus 6 in the numerator. There are no other holes. There are no other vertical asymptotes. We only have this horizontal asymptote left. The horizontal asymptote's at 0, and that happens when we look at the degrees of the function. So the numerator has a degree 2, the denominator has a degree 3. So the degree is smaller in the numerator than it is in the denominator. That automatically makes the horizontal asymptote at 0. So I can check off I've got that situation covered. The only other thing is to consider if there is some type of constant factor here. So I'm going to go to this y-intercept and try this out. Now this is at 0 and it looks like 4.5. So if I plug in 4.5 over here, that's for my y value, and x is 0, we don't actually need the whole, but we can include it, all right, or we can reduce it down. All right, so on top we have a negative 6a, and in the denominator we would have negative 4, negative 4. If I multiply that over, we would have negative 18. And I can divide by negative 6 to get a positive 3. So that gave us that factor we needed. I would write out my function you do need a y equals or an f of x or some type of output. But I have 3, x minus 6, x minus 2 divided by an x minus 1, an x plus 4, and another x minus 2. We've got one last one to look at, and if you want to pause the video, try this out on your own, you're welcome to. I'm going to go ahead and work through this, but again, check through this scale. This is at -1 for the vertical asymptote. There's only one vertical asymptote, but there is a hole that exists. This hole is at 3, 4. So just using those two pieces, I can find the things that go in the denominator. So I'd have an x plus 1 in the denominator for the vertical asymptote, and x minus 3 in the top and bottom for this one. There is a x-intercept over here at -5. That gives me a factor of x plus 5 in the numerator. And we might have some constant factor as well to consider. So I'm going to plug in the y-intercept here at 0, 10. So when x is 0, y is 10. Again, we could remove the hole. We don't actually need that hole algebraically, so I get 5a in the numerator and 1 in the denominator, which is just 10 equals 5a. So a would be 2. Putting this all together, I have a function, I'll name this one g of x, is 2 x plus 5, x minus 3. That's all in the numerator. And then we have x plus 1, x minus 3. We're not going to do any graph examples or writing the equation examples where we would have a slant asymptote. That's a much harder concept and really not important for us. We want to focus on just pulling out these key features that we can, like the asymptotes and the holes and the x-intercepts, and using those to form our equation.